All right, good morning, folks. My name is Dave Lockhart, and it's 8 o'clock, and we'll get started on this MECH study group that CSHE has put together. We are very excited about getting these study groups started up and really working to promote the MECH exam and certification within healthcare. I'm really excited. CSHE has been doing it for quite some time. But ASHE has also accepted it and working on promoting it within the national organization. So very excited and glad to see everybody here. Looks like we got 25 participants. I'm not going to look at the chats right yet, but basically my goal here is to kind of review. I'm going to cover electrical systems. There's a handful of systems that, services that the MECH covers for healthcare engineers. So we'll kind of go over that. I think I'll take, if you want to, Beth, will folks be able to unmute themselves and ask questions as we go?
Yep, absolutely.
Okay, perfect. So Beth Demeter is in the background managing all of the stuff. I've got a slide presentation that I slammed together last night and kind of finished up this morning. This is, just kind of things we've put together, an executive board and others. And actually, if anybody on here is somewhat of an expert or has got good experience in these topics and you would like to host one of these and help with the study group, we are looking for volunteers in all of the different sections. I chose electrical, that's my background, but I will admit, I haven't been doing the electrical for quite some time. So I'm going to actually refer to the internet a couple things that I look back on and just give you some facts. So again, we've got about an hour. We'll go through stuff. We'll take questions as we go. And hopefully we can get through all this in about an hour. So again, my name is Dave Lockhart. I am the support service administrator for Kaiser Permanente in Roseville. I'm the immediate past president for CSHE. As well as the ASHE Region 9 board member or advisory board member. And I do oversee our sustainability and sustainability liaison. So I stay quite busy. We've got some 28 folks on here. So again, that's my introduction. We're not going to introduce everybody on here, but hopefully I'll get to meet each of you either at the annual or at the different institutes or seminars. We're going to basically an overview of the test and what to expect and the MECH topics. These are the MECH topics. So they got plumbing, electrical, carpentry, probably really just basic carpentry. You don't have to be a carpenter, but understanding some basic stuff, measurements and other things. General maintenance, heating systems, power plant being boilers. And safety and support services. So these are all of the topics that MECH expects you to understand. And one of the interesting things, looking through their guidebook that they have that's available for purchase, is that MECH really expects they don't have really a study program. They don't really have things to teach or to review for the test because they expect you to be able to pass this test with your experience. So through your years of experience working as a hospital engineer, general services, whatever it may be, that you apply yourselves or get opportunities to work in each of these areas to become more proficient. They do have 2 levels. I think it's a senior MECH, and the MECH is the first one that you can obtain. But my goal today is to cover electrical, some basic stuff. We do have some sample questions I'm going to go through and just give you an idea. MECH, this is a test, and MECH also advises that like all tests, you definitely want to come prepared, get a good night's sleep before. And as you read the questions, there's 100 multiple choice questions. Actually, there's 110. Let me correct that. There's 110 multiple choice questions, but 10 of them are practice or just questions that they just throw in there. They don't count for your final score. You're scored on 100 of them. And they are multiple choice, and they highly advise, and you'll see as we go through these, choose the best answer. Take your time, eliminate those answers that probably aren't right, and or choose the most correct answer that's in there. So we'll as we go through this, you'll see what I mean with some of the questions that they have on there. So, but definitely want to give you kind of a heads up and a good feeling that you're prepared for these tests. So again, we're going to try to cover each of these chapter areas. So as I mentioned, I'm doing performing for electrical services, and these are the kind of the topics or the areas that they will be testing you on or expect you to have some general understanding of. So being able to read electrical blueprints and electrical symbols, know the function of a safety analyzer, understand Ohm's law and are able to use it in the field, operate and diagnose single and three-phase motors, understand fluorescent lighting and ballast specifications. This is an area I went back to the internet because you know, we match ballast with lamps. We know the different lamps, but just going to cover that a little bit. Understand electrical safety precautions and diagnostic methods. Identify the load, the common and ground connections in electrical circuits. Know the types of motor starters and motor protectors. Understand switches, relays, and various circuit types, three-way control, etc. Use and apply amp multimeter, and recognize and understand ground fault circuit interrupters, GFCIs, receptacles, and circuit breakers. So as far as electrical goes, they cover a pretty good gamut of the topics and the areas for electricity and electrical in our organizations. So let's just start off with Ohm's law right off the bat. So electrical circuit, electrical circuits, the current passing through most materials is directly proportional to the potential difference applied across them. A single diagram to help memorize Ohm's law is V, or voltage, equals I times R. So I being current. So if you don't know what the voltage is, you could multiply your amperage times your resistance to get your voltage. And likewise, you got your current, so you can equal all of those. And let me just real quickly, I found a wonderful piece out that Fluke put together. I want to go ahead and hide this right quick. This is a website from Fluke's. Basically goes to Ohm law, has a triangle here. So you got your voltage up here, current and resistance. There Dave, they talk about, yes.
We're not seeing the website. It's still the PowerPoint.
Oh, interesting. Okay. I wonder how okay, maybe I've got to do this then.
That's better.
Okay. So it looks like as I go through, I'll have to change that piece. Okay. So again, Fluke website, Googled it. There's a little triangle for Ohm's law. Basically helps you to kind of walk through that. Voltage, current times resistance, or volts equals amps times ohms. There's your different symbols. Here we talk about what voltage and the different symbols of what they have, what they mean. Pressure that triggers electrical flow. So again, well, I shouldn't say again, but voltage is the pressure. Amps, that's kind of the load, the heat that is put out there, the work that's being done. And ohms is the resistance. It kind of restricts the flow of power, or that voltage going through there, causing that heat. You can basically use that triangle, take any one out, and then you're going to divide. Here you got voltage with resistance, divide voltage by amps to get your resistance. So that triangle really helps you, give you a visual of what you need to do. And what I really liked on here was a quick little, or a simple little circuit. I don't know if they'll have anything like this on the test, but there you've got a basic DC circuit with a 12-volt battery. We don't know the amps. We do know the resistance of that bulb at 6 ohms. So if you take voltage divided by the ohms, you will get 2 amps. So very straightforward and simple application. So if you look to, here we've got another one to solve for the resistance. So they got some nice little formulas, applications there. So good visual, good help, easy understanding of applying it. And granted, this is just DC voltage. AC voltage is going to have some more information in there as far as a multiplier. So there's your Ohm's law. that covers that. And let me just go back to my screen. Go back to, let me see, where's it at? This one here. Okay, so that's Ohm's law. Oops, close that, got things popping up here. All right, electrical analyzer. An electrical safety analyzer is an instrument used to perform various electrical safety tests, including ground continuity tests, insulation tests, high voltage tests, and line leakage tests, to check that the device under test is in compliance with electrical safety. So a lot of facilities have these, use those for any electrical equipment that gets introduced into the facility. You want to make sure that it is properly wired, doesn't have any leakage to ground. You want to make sure it's got a ground post. So electrical analyzer is a simple test piece of equipment that can plug a piece of equipment into, run it through its test, and make sure the equipment is safe for operation. So hopefully you're very familiar with it, but basically the testing is, what you're going to be testing for is the ground continuity, insulation, high voltage leakage or high voltage test, line leakage test is probably a big one there. So that's where we'll use electrical analyzer to make sure that everything is safe, wired properly, and functioning. Next question is, know the types of starters and motor protectors. So there are 4 particular varieties of motor starters. You got a cross the line starter, you got a reversing starter, a multi-speed starter, and a reduced voltage starter. The across the line and full voltage non-reversing are the most commonly used general purpose starters. And the starter connects the incoming power directly to the motor load. So over here on the right is a very simple diagram showing your starter for your 3-phase motor here. So you've got your contacts across here, you've got your overloads, and then you got your connection to your motor. So pretty straightforward. Motors are going to have those just to help get them started. The contacts for those starters are higher amperage. They allow a larger load to serve the motors versus having a switch or something else out there. So that's usually why we use motor starters. You can use control. They'll have a coil, a solenoid that energizes that contactor. That'll be low voltage, or you can control it with lower voltage to start and stop motors. You should all be very familiar with those. That's basically pretty standard out there with our motor control centers and other things to start and stop our high amperage motors that we have. Also, motor protection. For our motors, you got short circuit protection, you got locked rotor protection or blocked rotor protection, you got overload protection, phase unbalance protection, and earth fault protection, basically ground fault. One thing I noticed when I was looking at internet, you can remember those by the word slope. So I bolded those right there. So those are your typical protections to protect the motor. And those will be in your motor circuit, your MCC. Sometimes it'll be in your breakers and other things, just to make sure that that motor, if it has a certain situation, it'll open up and protect that motor from burning out and failing or causing other damages. So pretty straightforward. Short circuit, is pretty straightforward. Instead of that motor frying, hopefully that short circuit will open quick enough to protect that. And you can identify if you've got a short circuit. Locked rotor, if the load is maybe on or something that should start the motor with less of a load, that high amperage will help trip it, not cause the motor to fail. Overload protection is pretty straightforward. Kind of goes with that locked rotor. Phase unbalance. If we got a phase, let's say you're not producing or not providing all 3 phases to that motor, you're going to have problems and will probably burn out that motor. So if you don't have all 3 phases, that's another protection. And then, of course, the earth ground fault protection. Oh boy. Oh no, I shouldn't be to this part yet. So let me cover. I'm going to switch screens again because I'm getting into the questions, but I know I've got a couple other sites I want to take a look at here for other areas that we have some questions in. Let me see if I can get rid of this piece. I gotta bring this down here. There we go. Okay. Okay, testing motors. So that is another area that they may ask is how to test a three-phase motor. So basically, this is a simple diagram of a three-phase motor. You have your three phases all right here. And you guys can see the screen, right?
Yes.
Okay, good. With the little meter on here, I forgot if I shared that piece. So here's a basic motor. To check the windings on a motor, you can take your ohm meter, volt ohm meter, and you can check your ohms across the coils. Make sure you don't have any openings. You can check across the ground. So this website I found, Electrical Engineering Toolbox, kind of walks you through how to test the motor or check a motor. So here they talk about first check the appearance, check for burnt damage to body or cooling fan or shaft. We often know that lubrication is one of the high failure points for motors. So you want to make sure that looking at the lubrication, the bearings, things like that, manually rotate the shaft, make sure bearings are working okay. And as all testing inspections, motor nameplate, look at your motor nameplate so you understand the voltage, what the amps require. So then you can apply Ohm's law to make sure you get the proper resistance on your windings. And here they talk about using your multimeter to check your different phases, windings in the motor, make sure they're okay, checking to ground. Sorry, folks. And kind of talks through that checking. Also for checking insulation resistance. I don't know if many people have used a megger before, but a megger basically checks all of our wires in our motor have very thin insulation in them, but it keeps them separated from each other and separated from ground. So you can take a megger which creates high voltage. And the ones I probably have push button ones now, but the one I'm most familiar with is a little hand crank. You just crank away, set at 500 volts, set it to the two phases and crank away to make sure you have some insulation resistance between your phases as well as to ground. So insulation resistant test is done with a megger. The other tests I talked about were just done with a multimeter. And then you got your running amp test. This is where you can use a clamp on and measure the amperage. You want to make sure when that motor is running that your phases are pretty well balanced. They should be balanced if your resistance is good. If they're not, you may have a failing winding in that motor. So that's what we do for motor testing and inspections. You also want to test and check for when you power it up, make sure you got good power coming in. As I talked about, an imbalance, phase imbalance, make sure your voltage is good across each of the phases, and make sure your motor is grounded properly. And again, just checking that motor out. So those are some of the simple tests to do for checking a motor to make sure it's operating properly. Here we've got, this is the lighting circuit. Let me go into here. So this is actually, it started right here. So different type of ballast technology. So some of you may be very familiar with, we've got electronic ballast, kind of describes electronic ballast converts to 60 cycle power to drive the lamps to a high frequency of 20,000 hertz or more. Using the high frequency currents, the ballast takes advantage of the fluorescent lamp efficiencies. So it speaks to that. We got HID ballast, hybrid ballast, magnetic ballast. So those are your common ballasts that we have, ballast types. Lamp types, you're all probably very familiar with the different type of light or lamp ballast or lamps we have out there: mercury vapor, metal halide, high pressure sodium, CFL lamps, and they don't even show, it's probably down next, LED, which is by far most popular nowadays. Different types of starters for our lamps. You got instant start, programmed preheat, rapid start, and others. So this kind of walks you through. I won't go into the details of each of these so we can get to the questions, but kind of different types of starters for our lamps and how we can fire them. And again, most lighting will work off of the different voltages, but you definitely want to understand what those voltages are for your lamps. And this stuff here is just, I doubt you'll be testing it. And of course, ballast can be rated for different lamp numbers. So we have 1, 2, 3 or more lamps for your ballast. So you definitely want to make sure you've got that straight. And most ballasts are to a certain standard or certification. And then the last page that I found that I wanted to cover for topics is the types of motor protection. Oh no, I covered that on, I got that on the slide. So those are the different types of motor protection. So I got those. All right. So with that, any questions before I get into the questions that we have to cover? All right. Hearing none, or you're challenged with getting off your mute. All right. Electrical sample questions. So I've got about, I think 20 of these or so to go through. So this is kind of some of the samples that they have with the questions you'll get. So a 2 ohm resistance across a set of contacts indicates that the motor will not start. B, start capacitor may not function. C, contacts may need to be replaced. Or D, motor should be removed for service. Any ideas on this? So looking at our contacts, basically maybe that motor starter contact, any type of a relay that we may have, but across our contacts, if we got 2 ohms of resistance, what do you think that's going to mean? It
Phil
may
Harrigan,
mean, go ahead.
Sorry. Phil Harrigan put C in the chat box.
Excellent. Great. Excellent. I can't see the chat, so thank you for that, Phil. Exactly. Contacts may need to be replaced. So yeah, your motor may not start, but the contacts, we don't want any resistance across those contacts, especially 2 ohms. That's going to create heat. As I mentioned before with Ohm's law, our contacts should be clean, make good contact. So having 2 ohms resistance across that contact would probably say it need to be replaced. So great answer, Phil. And hopefully that makes sense for folks. That's why when we inspect our contacts, we see arcing, sparking black or things like that on there. We definitely want to test those contacts while they're closed to make sure. And sometimes when you do your electrical checking, you can go through without voltage on there and see what that resistance is so that you could validate that they're good. You can do visual inspections as well as the meter testing on there. Motors that smell burned or have gotten hot should be checked for A, locked rotors, B, shorts or open circuits, C, faulty start switches, or D, bad capacitors. Any ideas? Locked rotors, that would probably make your motor smell or burn, getting hot. Shorts and open circuits, definitely. Faulty start switches, no. Oh, nice job. Martin, thank you very much. Yes, B, shorts and open circuits. That's exactly it. Lock rotor could do that, but your shorts are open, definitely be one. So that's, again, they're looking for, you may have a lock rotor and your lock rotor safety circuit opens up and it doesn't cause your motor to get burned or smelled. So again, these questions look for the best answer you would have. So definitely if your motor shorted and fried, you would probably have smells or definitely an open circuit in there as far as a phase. The other 2 phases be working extra hard and definitely getting hot. Breakers are reset only. So when you reset the breaker, you should only do it if there is nothing plugged in. B, when all appliances are off. C, after the circuit has been checked for shorts. and D, when there are no frayed cords. What would be the best answer for this one? Breakers are reset only.
Jason says C.
Excellent. Well done, Jason. Exactly. So we're not going to be able to go around and get everything unplugged, but if we could check that circuit for no shorts on it, nothing shorted out to ground causing that breaker that tripped, we would be cleared on that. And that's a quick, easy test to make sure. Granted, you may see some resistance on there due to the loads, but you definitely don't want to go into ground in a short. So great job. When replacing a fuse, the fuse should be A, glass fuse, B, a bar fuse, C, one recommended by a manufacturer, or D, the same type and amperage rating. All right, somebody jumped in there and said the one recommended by the manufacturer.
We also have somebody that said D.
Yes, D is the correct answer. The same type and amperage rating. So if you're replacing the fuse, make sure you replace it with the same type you had that was in there. Now, because of the design and what you have, it may not perfectly match the manufacturer recommendation, but you also have a challenge there that if somebody in front of you put in the wrong fuse and that's why it blew or may have problems, but the correct answer is the same type and amperage rating that you have. So I'm sure C is a very logical answer as well, and would be what you could look to, especially on a manufactured piece of equipment, enclosed equipment that was designed that way. Both could be right, but again, here they've got very close answers that either one of them probably could have been correct, but D is the correct answer. Same type and amperage rating. Because again, if you're putting in the same type was there and it still blows, then you can really troubleshoot the system, find out what's wrong, and then maybe go to the manufacturer's recommendation beyond that. Because finding the manufacturer's recommendation may take more time to go through and research and get that. You may not have that. So definitely replace it with the same type and amperage rating that you have. Definitely want to do that, and not, as a lot of people may do, go try to find a higher amperage. You know, it's inconvenient because of, well, I don't have to get into that stuff, but you guys are qualified technicians out there. Okay, here's a simpler one. Electrical extension cords that cross a walkway should be placed in A, cord protector, B, conduit, C, plastic pipe, or D, floor trench.
We have an A from Jason.
Excellent. Very good, Jason. Yes, once again, just a simple cord protector. Protect that cord from getting smashed, frayed, punctured, or something like that happening. Pretty straightforward. All right. Hydrometers are used to A, determine the battery's charge, B, determine the acid content, C, both A and B, or D, neither A or B.
Kyle says B.
Okay. It definitely will do that. It'll determine your acid content. How much acid do you have in there? As we add water to that, it could deplete the acid content in there, but that acid content also tells us what the charge of the battery is. So it is actually C, both A and B. So when you're doing a hydrometer, it'll help tell you how well charged. If you use a hydrometer, you'll notice on there they'll have usually a red, a white, and a green on the bar as well, saying what the specific gravity is or the acid content, and that will tell you if you have a good charge on your battery. So the answer is both A and B. A lockout tagout is a tool used to check the system for power, B, procedure sometimes followed by the supervisor, C, safety procedure to prevent electrocution, or D, safety procedure for electrical equipment. And we've got an answer of C, which is exactly correct, a safety procedure to prevent electrocution. And again, this is a safety procedure for electrical equipment that you could, to me, again, they threw in that one. It's almost identical question, but it's not a procedure for electrical equipment. It's to prevent the electrocution. So here's another question that you really want to read through. see what it's saying, think about it, pause, and just make sure you select the right answer. So great job for those that selected C. All right, battery, somebody getting ahead of me. Batteries need to be checked for oil level, water level, acid level, or voltage level. And that line just happened to line up with the right one. So yes, as we talked about before, batteries need to be checked for acid level. It could easily say water level because that's what usually we're adding to there, but it is acid. We're just diluting that acid level when we add to the battery. So acid level is the correct answer. All right, electrical connections are checked for A, loose screws and black smudge marks. B, hot terminals where wires connect. C, A and B, or D, A and neither A nor B. And that is correct, both A and B. Hot terminals where wires connect. That's usually done with a thermometer or thermography, imaging scanner to check for hot stuff. You may be able to check the wires when the power is off to see if they feel hot, but oftentimes it's loose. You can see a loose screw, wires are loose, or black smudge from the arcing and the heat that is created from loose connections. So great answer there. Electrical switches and receptacles are replaced with. Electrical switches and receptacles are replaced with the white wire connected to the green terminal. Okay, so this is the wiring of them. The white wire connected to the green terminal, the black wire connected to the silver terminal, the green wire connected to the silver terminal, or the black wire connected to the brass terminal. Excellent. Before I even got through there, we got an answer. That's exactly right. That brass terminal is a little bit better of a conductor of that. And so that's where your black, which is your power wire. Everybody knows, or hopefully you know, the white is usually a neutral wire and your green is a ground wire. So your green is not going to go to either of those other terminals. So that's pretty straightforward there as well. An electrical centrifugal switch is A, safety switch, B, a mechanical shutoff, C, a start switch, or D, an electronic device. Centrifugal switch.
Kyle says C.
A start switch, okay. So electrical centrifugal, so centrifugal means turning, it's spinning. And the correct answer is not C, but it is B. So it's a mechanical shutoff switch. So usually those are for like a high speed on a motor or some other spinning device, that if it goes faster than it's expected, or maybe in some cases, well, this says mechanical shutoff switch, but I've also seen centrifugal switches that do close. Once it gets to a speed, it'll close and let you know that something can operate. But the correct answer on this is a mechanical shutoff switch. And I guess saying shutoff, even if it was slowing down, it would then open up, but it's a mechanical shutoff switch. Basically, mechanical spinning is what is going to activate that switch, change state at that point. So again, Kyle, it absolutely could be a start switch. Once it gets up to speed and closes, it can start, but they are looking for mechanical shutoff. You could also say it's a safety switch. If it gets high speed or something else happens, it could be there for safety. So again, this is the thing I want to bring your awareness to. You definitely want to read through those questions and think about them and work to pick the best answer. LED lights are sized by A, lumens, B, electrical usage, C, physical dimensions, or D, their color generation. Excellent answer. Beth, you answered that one. Great job.
No. I figured it was easier to do that than voice every time somebody puts something in the chat.
Somebody put in the comments. Very good. I said Beth is now going to qualify to take the test as well. No, perfect job. Yes, lumens is what we do for LED lights. Nice job on that one. Yeah, when we got other lamps were kind of by dimensions. Your T lamps, we did by dimensions, the size of the lamps and other things there. A lot of LED is color generation as well, but we measure it by the lumens. So great answer. Let's go to the next question. Oh, am I not going to the next question? Uh-oh. My computer just locked up. There we go. Okay, if an electrical short happens, A, an arc fault has occurred, B, someone will see smoke, C, the wire will melt, or D, a loud noise will be heard. So you will have a lot of those things happening, but basic electrical short is an arc fault has occurred. So an arc has occurred for an electrical short, and there's potential you will see smoke. There's potential the wire will melt, and there is definitely potential you will hear a loud noise depending on how large of a short that is or what the voltage content is. Potential there will create some significant noise, but the correct answer is A. You will have an electrical, an arc fault has occurred. Okay, a 2-pole motor speed will be. This is a tricky one, and I didn't really cover how to measure it and go through there, but we'll see if anybody has the answer for this one. 2-pole motor speed will be A, the highest possible, B, 1800 RPMs, C, the same as the frequency per second, or D, the same as a frequency per minute. Excellent answer. Good job, whoever answered that one. That is the same as the frequency per minute. Very good. Okay. A light circuit is controlled by 2 switches. It is called A, nothing, B, a 2-position circuit, C, a 3-way switch circuit, and D, multi-switch light. Excellent. 3-way or 3-way switch is correct. Basically, either switch can turn the light or the load on, and so the up or on doesn't necessarily, it may turn it off. You're probably all familiar with that. You have them in your homes and everywhere else. An electrical symbol that shows a slash between 2 vertical lines is a symbol for A, an open circuit, a BNC contacts or normally closed contacts, C, a broken wire, or D, a capacitor. Correct answer. Yes, usually you'll see in schematic diagrams, you'll see pictorial diagrams, you'll see the 2 lines, and we didn't see it in that motor starter that had all normally open contacts. That's correct. The neutral side of a receptacle is indicated by the A, smaller slot, B, larger slot, D, shaped slot, or D, any slot, depending on polarity. That's the correct answer, the larger slot. Oftentimes, we don't pay that close of attention to it, but you will see that. And what would you say if you had between a 15 or a 20 amp? What's the difference between a 20 amp receptacle? Basically, most people are answering other ways, or in the comments. Basically, you should see the little extra slot on there, kind of a T shaped for the larger one. So that's for 20 amp receptacles. All right, lockout is achieved when, okay, so using a lockout tagout, so this is safety. All of the locks are used. There is no energy. The paperwork for a lockout tagout is filled out, and no one gets hurt. Yes, B is the correct answer. There is no energy. Again, paperwork, having the paperwork filled out is good, but that doesn't mean that the energy is secured and everything is taken care of. And I do like that answer as well, that no job is done until the paperwork is completed. So you definitely want to have your lockout tagout paperwork completed so people know you've applied it and what you've done. But basically, there's no energy. We want to protect those working on the circuit. An operating room is always connected to A, oxygen, B, backup power, C, drains, and D, the communication system. So my operating room is connected to each and every one of those things, but because we're covering electrical backup power is the correct answer. So again, here's all four answers would be correct, but because we're in the electrical section, we definitely are talking about backup power. The electrical diagrams. When electrical diagrams show the internal switching of a component, the electrical diagram is called a switching diagram, a pictorial diagram, a cross line diagram, or D, an exact diagram. Someone has chosen cross line diagram, and that is not correct. It's pictorial diagram. So when they're really showing the internal components or switching of a device, that's considered a pictorial, the internal drawings of it. So that's a pictorial diagram. And again, these are things we don't usually cover and work on a regular basis in our field. So, and another thing, this may end up being one of those throwaway questions. And granted, you don't need to be 100% on this test to get it exactly, but just understanding the different type of electrical diagrams you may have are covered in the test. Which statement is true? Voltage is electrical pressure. B, amperage is the force of an electrical circuit. C, resistance reduces amperage. Or D, wattage is the multiplication of resistance and voltage. Okay, so got a couple different answers in here. So there we go. I talked about it early on to try to give a hint of this. So the force that pushes the amps through the wire, the load through the wire, is the voltage. So voltage is electrical pressure. If you think about plumbing, it's the pressure that pushes that water through the pipe, or the little amp load through the wire. Resistance is basically that. It resists allowing that amp to go through the wire. It has to work hard to get there. It causes more heat. And then that wattage is the multiplication of resistance and voltage. That was not correct either. So voltage is electrical pressure. So try to think of that. And I've always used it in a plumbing, because plumbing you can physically see. So thinking of voltage as that pressure for the water itself is the amperage going through there. It's doing the work. And the pipe size is your resistance and its flow. And I think that was all of the questions I had there. So I want to pause there. I actually got that through much faster than I thought we would. I thought we'd really go through quite a bit more. Any questions? Hearing none. So again, the MECH exam is 100 questions, or will it be 110? You've got, I think it's 2 hours to take the test. And that should be sufficient time, but I would definitely highly recommend you take your time going through that. If you don't know an answer, maybe leave it blank, but make sure you mark and come back to it. Try to eliminate the questions that just don't seem right, or the answers that don't seem right or aren't as true, to help eliminate what you're going with. And then from there, go with your gut, go with what your instinct is and how you're going to answer that. As I mentioned, the other topics that will be covered on the test are plumbing, carpentry, general maintenance, heating systems, so HVAC, power plant, and they just specifically say boilers. I don't recall if they cover chillers. They're showing boilers on there, so more of a boiler plant, and safety and support services. And we do have, I think we've got one other person on the executive board that will work to do the safety and support services. So if there's anybody out there that feels proficient in the plumbing, carpentry, general maintenance, or heating or power plant, we would love to have you host one of these study groups. We will have, I think folks already had to sign up because you have to, there's also, just to let you know, we will announce, we have a period of time that we have to set up with the MECH program to host a test. And then people have to sign up within 4 weeks prior to that test. So we do have one that will be happening at the Annual Institute here in a couple weeks in Tahoe. We've got a couple of folks signed up for that. And then we will probably, we're looking to, hopefully these study groups will be of interest and be helpful for folks to, that we can also offer the test at the seminars, the Southern California and Northern California seminars later in the year. I think that's September and October this year. So definitely, if you are interested in doing that and getting this certification, let Beth know, or the executive board know, let your chapter president know, and we will get folks signed up. We'll work to make that test available. And again, if there were areas here that some of the questions you really struggled with or didn't have any idea, talk with your supervisor, your foreman, your lead in your facility. Try to get some opportunity to work in the different areas if you can. And again, as much as MECH says, you can't really just go study a book for this stuff. And you get in the areas, do some internet searches, look for some different topics, look for different areas, and try to study up that way. But you really are best to get somebody who is proficient in that trade, ask them questions, tag along with them, and work to get that experience, because that's what MECH really wants to do, is understand your experience and validate that experience with this test. So any other questions, anything else from the group?
If I could just real quick, Ryan asked if we can provide a copy of this training. Ryan, this is being recorded, and as long as you are a current CSHE member, it will be posted on the website and accessible under the MECH section. And I can definitely send you an email with the direct link later. The other thing, real quick, the Safety and Support Services Study Group is already scheduled, and the invite will be going out on Monday. That will be May 27th at the same time, 8 a.m.
Excellent. Thank you for that, Beth. Yeah, so hopefully this was helpful. Again, we heard from a lot of members that they wanted to put a study group together, and I wanted to grab some information and help kind of walk through the stuff. Oftentimes with a study group, you can see who the different participants on here. If we want to reach out and just have some dialogue, ask questions, and cover your experience or lack experience. If you have a question that you don't have an answer for, reach out to anybody on here, reach out to myself or someone on the executive board. We definitely want to help you be prepared to be successful in this test, especially those that are out there that have successfully passed the test. I did many years ago. I did take the sample test and did well, but definitely brought back, I realized I was not quite as sharp as I used to be on the subject matter. So definitely do what you need to do to be successful in this test. But CSHE and the executive board definitely wants to provide you with the tools and the support to get this certification, because it does help us in our field. And it's nice to know that folks have a competency and have demonstrated that through test taking. All right, anything else in the chat, Beth?
There is one more question from Jason. He's asking where we can find a sample test. I believe the only way to get a sample test is to actually register to take the test, and then they will send you the complete packet. Do you have any different information on that, Dave?
No, that's my understanding as well. They do have that their packet once you sign up, their guide packet, I guess is what they call it. That it has sample questions for each of the topic areas in there, and that's very similar to exactly what we just covered here. that Cece purchased for our being able to prepare everybody for these tests and for this book. And MECH clearly says that these questions we just went through will not be on the test. So it's not as though they're giving you samples. These are just other questions. These are put together similar to what is on the test. So you won't be able to memorize these questions I just did or cover stuff, but it gives you a good idea of the subject matter when they're covering in electrical. So again, the other probably more important slide, and in that guide, they do cover what kind of topics will be under each section. So again, reading electrical blueprints and electrical symbols. I didn't go out. I probably should have taken a picture of any of my blueprints, but definitely go back to your shop, pull out some electrical drawings, some one-lines, some schematic diagrams from some pieces of equipment. Look at the legends, look at the symbols, understand, we're all pretty familiar with probably receptacles, switches, contactors, things like that. Go through that stuff. Understanding the safety analyzer. You have one at your facility, go look at it, feel it, understand it, what it's really doing and how to do that stuff. Ohm's law, is kind of a generic piece, but it's one of those basic things we don't really apply on a daily basis. So that's why I wanted to show that website that had some simple diagrams. One of the things too, and maybe I didn't cover that, use and applying amp multimeters. So, and that basic electrical, so everybody probably owns or has maybe what we used to call back in the day a wiggy, a simple electrical tester. Back in the day, they'd have a solenoid. If you hit anything electrical, it would energize that solenoid, pull it in, and you hear a clicking noise. We've got light indicators that if you're close to electrical circuit, you have those, but multimeters to where you're able to test voltage, both DC or AC voltage. You're able to test resistance or ohms with that. And in most cases, you can check amperage. And one thing I do want to point out is, and actually, I may have missed another question here, is the different type of wiring circuits, whether things are wired in series or in parallel. Those simple DC diagrams I showed when we were looking at Ohm's law were a series circuit. Everything was hooked in one single line in series and not in parallel. When you do the math of resistance, if you have multiple resistors parallel, that actually reduces the resistance load on there. But when you check that using amperage, if you are checking amperage, in most cases, 99% of the time we're checking amperage, we have a clamp-on ammeter, or a lot of the units will have like a fork on the end of it where you can go over the wires and measure amperage. Basically, you're doing it without being in line with that small DC circuit. If you were to check it with that multimeter, you basically have to put that meter in line with that, in series with that circuit to be able to measure amperage. So there are tricks to using your multimeter. So you definitely want to understand that and go through that piece. We talked about switches, relays, various circuit breakers, different trip capacities on circuit breakers. So you want to look and understand some of that. Ground fault interrupters, I didn't get to this. So we all have GFCIs around us. Those are usually applied where there's wet locations, water, moisture. And basically that GFCI, it's got a little coil that's measuring what's going through that neutral line in there. So they want your load to be going out on the load side and being consumed and used, and nothing really coming back on the amperage side. So it's measuring any current flowing on that neutral side to make sure it's balanced and appropriate. If not, boom, it instantly trips, meaning that we've got some voltage going to somewhere else, possibly water or other things. So you can kind of maybe study up on understanding what GFCIs do and why we have those. Circuit breakers, I mentioned, you got lots of different types of circuit breakers. I don't know whether they cover, simple installed racked in type of breakers, removable breakers, and their different settings and trip functions. We kind of covered that. We did cover identifying load, common, and ground connections, electrical safety precautions, again, lockout, tag out, testing, making sure systems are de-energized before you do anything, diagnostic methods of testing electrical circuits, making sure things are safe, turned off, amperage readings. I think we covered all of these other items here. So in the study guide, it covers, and this is what we'll hope to do with our study groups, is cover all of the different topics that will be applied or will be covered in the test. So this is what we'll be looking at. All right, 5 minutes last chance. Any questions? Any other comments? Was this helpful? All right, hopefully so. I don't know if we've got
yes, I have lots of people saying yes.
Excellent, very good. Well, thank you very much. I appreciate that feedback. Again, I'm winging this for the most part. I wanted to get as much information for you as possible. Again, it's kind of tricky when they really don't give you stuff to really study by. They give you some guidelines, and so hopefully this is helpful. If you definitely did not feel comfortable with some of those answers, it gives you kind of some guidance of where to go look and what to do. Again, I am available for questions or emails or anything you may need. And again, we'll cover all these topics, and hopefully by the time you're ready to take that test, you will be very successful at that. So with that, I want to thank you all for taking the time out of your day for this. I hope to see all of you at the CHE Annual in Tahoe, June 1 through 3, right, Beth?
Correct.
Yep, we got golf on Wednesday. Thursday is all of our presentations, and then also on Friday. And also I want to promote on Friday, we want folks to be sticking around. We got a great presentation, but we're also going to do some roundtable with all of you. We understand how CHE can better serve you, better educate you, provide services for you and for your team. So on Friday, please plan on sticking around and providing some information or helping us. We'll have a little gift for those that attend, and really look forward to it. It's, again, first time in a couple of years that we've been able to get back together. It's a beautiful venue. So we're really looking forward to seeing you in Tahoe this year, here in a couple of weeks. And with that, I will again thank Beth for all your work and support behind the scenes. And thank you all for the work that you do. It's been a long 2 years getting through COVID, but we look forward to your success and the work you provide for your facility. So take care, be safe, and have a wonderful weekend. Thank you all.
Thank you, everyone. And thank you, Dave.
Yep. Thank you. Yep. Bye-bye.